Students, you are welcome to this video of Dr. Anita Kothari. The first chapter of your syllabus is atomic structure, and the first part of this is idea of de Broglie's matter waves. What is de Broglie equation? The de Broglie equation is one of the equation that is commonly used to define the wave properties of matter. It basically describes the wave nature of the electron. Electromagnetic radiations exhibit dual nature of particle and wave. Microscopic particle like electron also proved to possess this dual nature property. First of all, de Broglie suggested that any moving particle, whether it is microscopic or macroscopic, will be associated with a wave character, and it is known as matter wave. He further proposed a relation between the velocity and the momentum of a particle with the wavelength if the particle had to behave as a wave. So, first we will derive the de Broglie equation. Very low mass particle moving at a speed less than that of a light behaves like a particle and wave. De Broglie derived an expression relating the mass of such smaller particles and its wavelength. We know that Planck's quantum theory relates the energy of the electromagnetic wave to its wavelength and frequency. Well-known equation is E equals h mu, and we know that mu is equals to c upon lambda. Okay. So, the equation is E equals hc upon lambda. This equation is according to the Planck's quantum theory. We also note that Einstein related the energy of the particle matter to its mass and velocity. And this equation is equals E equals mc square, where m is the mass and c is the velocity. As the smaller particle exhibits dual nature and energy being the same, de Broglie equated both these relations for the particle moving with velocity v as this one. We know that according to Planck's equation, E equals hc upon lambda, and according to Einstein equation, E equals mc square, or we can say equals mv square. So we can equate both the equation, that is hc upon lambda equals mv square. You can see here that here it is hc upon lambda equals mv square. Now this gives us lambda equals h upon mv, and we can say that lambda equals h upon mv, means mv is the momentum of the particle, यानी mv जो कण है उसका संवेग है. So this is known as the de Broglie equation, that is lambda equals h upon mv, that is lambda equals h upon momentum या h upon p. Okay. Now we see the application of this de Broglie equation. That is, we can also say that it gives the relation between the de Broglie equation and Bohr hypothesis of atom. We know that Bohr postulated that the angular momentum of an electron which is revolving around the nucleus are quantized. Means only those electrons can move in the circles which are having their angular momentum mvr square is integral multiple of lambda, that is n lambda. Okay. So what here see has the angular momentum will only be an integral multiplier of a constant value of suggested the following expression. Okay. That is angular momentum of electron which is moving in an orbital is mvr, and it is multiple integral of h upon 2 pi. that is nh upon 2 pi, where n is a whole number. Got it? It is 1, 2, 3 and so on. You can see here in the diagram, first diagram, that lambda is a complete integral, that is it is a whole number 1, 2, 3 and 4, right? So according to the Bohr, the electron can only move in circular orbitals when this lambda is a whole number, that is complete wave. Okay, and in second diagram, which is at the right hand side, you see that the waves are not complete, right? है ना, इट इज़ नॉट ए होल नंबर, है ना, ये पूरा कंप्लीट नंबर नहीं है. सो व्हाट विल हैपन, वेव्स एक दूसरे से कैंसिल कर देगी और इलेक्ट्रॉन सर्कुलर पाथ में मूव नहीं कर पाएगा, राइट? सो अकॉर्डिंग टू द बोहर, only those electron can move in circular path which are having their angular momentum mvr equals to nh upon 2 pi, right? बट उसके पीछे क्या लॉजिक था वो उन्होंने हमें एक्सप्लेन नहीं किया था. बट डिड नॉट गिव एनी रीजन फॉर सच एन प्रपोजल, राइट? बट de-Broglie equations gives a scientific validation for such an proposal. Okay, so we know that the de-Broglie equation is equals lambda equals h upon mv, or we can say that mv equals h upon lambda. So the electron wave in an orbital must be in phase, and so circumference of an orbit should be multiple integral of the wavelength, that is 2 pi r equals to be n lambda, right? So we can say that 1 upon lambda equals n upon 2 pi r. Now substitute the value of the wavelength in the de-Broglie equation. We get mv equals nh upon 2 pi r, or we know that mvr equals n into h upon 2 pi. Hence the angular momentum of the electron is mvr is an integral multiplier of a constant h upon 2 pi. Okay, so we sum up all these things once again what we have read in this first video, that is each light shows dual nature. हर लाइट का एक ड्वेल प्रकृति होती है, वो पार्टिकल नेचर भी शो करती है एंड वेव नेचर भी शो करती है, राइट? दिस इज गिवन बाय द प्लैंक्स क्वांटम थ्योरी. ओके, फर्स्ट ऑफ ऑल व्हाट de-Broglie ऑब्जर्व्ड कि सच टाइप ऑफ प्रॉपर्टीज ऑल्सो शोन बाय particles. It may be electron and it may be any big particle, it may be a ball also. Okay, so this de-Broglie equation can be applied to both the microscopic and the macroscopic object. Microscopic यानी जो कि छोटे हैं जैसे कि इलेक्ट्रॉन, एंड मैक्रोस्कोपिक जैसे कि बॉल, राइट? सो we can see that we get the two equation. First equation is equals h mu, right? That is hc upon lambda. Okay, and second equation is equals mc square given by the Einstein, and when we equate both this equation, then we get the value of the lambda, that is h upon mv. Okay, we know that mv is the momentum of the particle, so we can also write h equals h upon momentum या h upon p. Okay, so this is known as the de-Broglie equations, and here the lambda is known as the de-Broglie's wavelength. Okay, now we can give the relation between the de-Broglie equation and the Bohr's hypothesis of the atom. We know that Bohr has postulated that the electrons only moves in the circular orbital around the nucleus, है ना? और जो सर्कुलर ऑर्बिटल है उसके जो एंगुलर मोमेंटम होता है, इट मस्ट बी द मल्टीपल इंटीग्रल, इट मस्ट बी द इंटीग्रल मल्टीपल ऑफ लैम्डा. यानी जो इलेक्ट्रॉन सर्कुलर मूवमेंट कर रहा है उसका एंगुलर मोमेंटम, दैट इज mvr, इट शुड मस्ट बी द मल्टीपल इंटीग्रल ऑफ h अपॉन 2 पाई. h अपॉन 2 पाई का मल्टीपल इंटीग्रल होना चाहिए, मीन्स n इज अ होल नंबर 1 2 3 4. ओके, तो उन्होंने हमें ये नहीं बताया कि केवल वही इलेक्ट्रॉन्स इसमें मूव करेंगे जिसका कि कोणीय संवेग mvr h अपॉन 2 पाई का मल्टीपल इंटीग्रल हो, बट उन्होंने इसका कोई एक्सप्लेनेशन नहीं दे पाए थे. नाउ आप यहाँ पर देखिएगा कि जब भी इलेक्ट्रॉन मूव करेगा तो जो वेव्स हैं वो कंप्लीट होनी चाहिए. जैसे कि फर्स्ट डायग्राम में आप देखिएगा कि जो मैंने इस साइड में शो किया है, अपने लेफ्ट हैंड साइड में शो करा है, इसमें कंप्लीट इंटीग्रल है लैम्डा, तो वो इलेक्ट्रॉन आराम से मूव कर रहा है। लेकिन अगर आप राइट हैंड साइड वाला डायग्राम देखेंगे तो आप देखिए कि वेव्स एक दूसरे को कट कर रही हैं, तो क्या होगा, वेव्स एक दूसरे को कैंसिल करेगी और वो इलेक्ट्रॉन जो है सर्कुलर फेस में मूव नहीं कर पाएगा, राइट। तो इलेक्ट्रॉन को अगर चारों तरफ मूव करना है तो उसको फर्स्ट वाला डायग्राम फॉलो करना पड़ेगा, यानी लैम्डा मस्ट बी a complete integral. It must be either 1, 2, 3. It must not be in fractions. Okay. So what we see here, that the electron which is moving in this circular orbital must have the value n lambda. That is the circumference की जो वैल्यू है वो हमारी, यानी जो परिधि है इस सर्किल की, उसका जो मान होता है वो होता है 2πr, and that is equals to n lambda, right? Now here we put the value of lambda from the de-Broglie's equation. We know that lambda equals h upon mv, तो हमने उसकी यहाँ वैल्यू पुट अप करी है, and finally we get the same expression, that is mvr equals nh upon 2pi. So this is the application of what we say the de-Broglie equation to the Bohr's model. Okay, now in our next video I will explain the verification of this de-Broglie equation and also give you some numericals to solve. Okay, thank you so much.